Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, Feria Racing Components, PIC, Crower, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePowerTrade, the racing industry, every minute, every day. This is episode 457, and we're going to be talking sensors with Texys. With me this morning are Judy Kin, the co-founder of ePowerTrade, and a wonderful host, Mr. Brad Gilly. Judy?
Thank you, Francis, and thank you everyone for watching today. Boy, are we proud and honored to have an iconic brand join us this week. You notice Francis mentioned Crower. We are proud to have Crower on board with us, showcasing, like exhibiting on the platform, but also they are sponsoring this racing series, this weekly series, Race Industry Now, and also Race Industry Week later on this year. So proud to have them on board with us. Brad?
And I'm thrilled about it too. And thank you very much, Judy. Thank you very much, Francis. And I'm excited about this, especially for you, Francis, this week, because this is a company that's actually based in France, even though we're going to be talking to the American division of it. But it's awesome, everything that we get to do here. So we'll talk to you two here in just a little bit, and we'll get things going. Today's webinar, Measuring Temperature, Pressure, and Vibrations in Motorsports by Texys. And our panelists today, Jeff Kitchen, Operations Manager, and Miles Gunty, the Technical Service and Support Manager, which this is going to be a lot of fun. Jeff and Miles and myself had a great conversation earlier today about some of the wonderful things that Texys has. And I'll say this before I turn it over and introduce the both of you. You know, a lot of times in racing, and if we've all grown up in motorsports in some form or fashion, there's a lot of things that you do that you look at it and go, you know what, that looks about right. And you try it out. Maybe it wasn't. Maybe there's a lot of trial and error. Maybe there's, a lot of different ways you finally come to the conclusion. But finally coming to the conclusion might not help you right off. But what we're talking about with Texys and the products they have to offer, these are literally direct ways that you can get the data and figure out exactly what you need as quickly as you can and put it right back on the racetrack as quickly as you can. So, gentlemen, welcome. And Jeff, let me start with you. If you would just give us a brief overview of Texys and some of the things we'll be talking about here today.
Well, yeah, thank you for having us. We're really excited to be with you on this platform. It's a great platform, and enjoyed talking to you earlier today, and looking forward to this. The company was started in 1999, kind of forged out of Formula One racing. Some engineers with a Formula One team. Obviously, data and collection and sensors was really big, so they started the company with embedded sensors, mostly anything you can measure. So pressure, effort, force, temperature, inertia. That's how it started, measuring anything that you can measure on a car. From that, we've grown tremendously into other markets, but motorsports is definitely our focus. We've added partnerships over the years as people have come to us asking to measure this or that or the other thing. We've expanded our breadth of products, so we've partnered with other people. And most recently in 2024, we've been joined with Fogal is one of our partners. They're not in motorsport, but they do a lot of human machine interface type sensors. So pretty much a full line of sensors. Like we say, we now don't just answer questions about a sensor. People come to us with solutions that they need and problems they have, and we try to solve those problems for them.
Yeah, that's one thing I really love about it. And before we get to you, Miles, I do want to remind people, if you have a question at any time during this webinar, please feel free to type it into the chat, because we want to make sure that we're talking about what you want to know about, and don't ever hesitate to do that. Miles, I know when it comes to Texys, it doesn't matter if you're racing, motor cars, motorcycles, EVs, if you're flying an airplane, or even going up into space, Texys has something for everyone, it seems. So just give us a quick overview, if you would, Miles, about some of the technical side of things.
Yeah, our product range is so vast, and with some of the partnerships that we've gotten, it's gotten even more vast from there. And just being able to develop new products has been really, really important. Getting to be able to measure different temperatures in different ways has been really big. And it's just this iterative process we've seen technically to continue to develop new products. It's really been exciting getting to see that, and getting to see how the products have gotten smaller over the years, and how they've been able to get more robust, more resilient, as well as just improve the quality. It's really impressive.
hmm I look at when we're talking about the sensors and the sensor technology as twofold. I do think there are a lot of people who are very advanced on the technical side of things in motorsports that kind of have an idea and know what they need. I also look at this in the product offerings that you have for someone like me who might not know what I want, might be intimidated by the technology because I don't know what all it involves. But, Jeff, you touched on something just a second ago. I need to figure this out. How can you help me? And the this is almost unlimited when it comes to the parts of a race car, right?
Absolutely. So we'll get calls for people asking for IR sensors and temperature sensors and all that. But we recently just had two big groups actually, a race team and a race manufacturer, OE, come to us with, hey, we want to do this. So it wasn't specific on how we were going to measure it, but they knew what they wanted to measure, which created this great conversation about what we could do. One thing, we're a big enough company that we have a lot of products, but we're small enough that we can react to special requests. Recently, about 3 months ago, we were with a big team that had an idea for something, and I'd say we had it to them in about a month-ish. Yeah. So all with just a conversation that Miles had with the team. They said, hey, we'd like to do this. He talked to France. We've got some great partners globally, France, obviously, and then in Germany and the UK that support us tremendously. Great team effort. And in 30 days, we were able to have an end product to the customer based on that conversation.
That's kind of what really helps stand us apart from others, is we're able to have these conversations and then react to them quickly. We've got this motorsport DNA inside of us, and everyone in motorsport understands it. The race is happening on Sunday. Practice is Thursday, Friday, and the trucks are leaving earlier in the week, and we know we need to make sure we get the parts in our customers' hands so that they can put it on the car and pack it up. And that's been really great in the motorsport industry, and it's kind of the standard how we all operate. But when we start branching out into our non-motorsport customers, they see that, and it's just radically different. And it's something that they all start appreciating, like saying, wow. And that's kind of one of the big things that we here at Texys really get to provide, is just that level of customer support, being able to understand, hey, this is critical. Whatever their mission is, it's critical to us too.
A few years back, I was talking to Chad Knaus, 7-time championship winning crew chief with Jimmy Johnson, obviously leads competition now at Hendrick Motorsports. And in the conversation, we just got to talking about what makes a race car go fast. And this is a quote, and I think this really leads into very well how what you offer at Texys can help everyone. He said, look, there are 5 things that keep a cup car on the racetrack: downforce and 4 Goodyear tires. And when it comes to gathering data, I mean, think about the wheels turning right now, literally, and pun intended, I guess, about all of the things that Texys would have to offer if someone needs to collect that data on keeping the car on the ground, downforce and 4 Goodyear tires. It involves everything: suspension, setup, all of those different things. So let's use that as a jumping off point.
Yeah, absolutely. Let me share my screen here. I got a little bit of a PowerPoint. And your point, Brad, it's there's a lot of data, a lot of ways that we could collect data on a car, collect data on, everything. So let me share this. And you're able to see some of the different areas on these cars. We have just a sports car here, but this goes for any open wheel car, all the way down to some guy who just wants to track his Camaro. So, we have different things here. You have your load cells, so we strain gauge different suspension and steering components, so that way the engineers are able to understand the loads that are being put on to the different components there. So the suspension components, you could then extrapolate your aero loads, and then you can make decisions based off of those and see where that goes. Same thing with the steering. You're able to then interrogate how your driver is driving, and you're able to then find performance increases there. And then obviously we have different aerodynamic and pressure sensors. We've got our pitot tubes and we've got our differential pressure sensors, and we're able to then understand how the air is moving around the car. So back to that quote, the downforce, being able to understand the downforce is also really key, especially in today's modern racing. Understanding accelerometers, understanding temperature, whether that's IR, whether that's physical temperature. We here at Texys have a bunch of different ways to be able to measure these. I think some of our more impressive ways that we've been seeing recently is kind of some of the effort that a lot of teams have been putting into the tire, understanding the tire, how the tire warms up, and understanding its performance peak and maximizing that, whether it's in qualifying or whether that's during a single stint, and understanding when that tire degrades. So us being able to have EPMS sensors with IR inside, it's really, 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 really critical for them, because they're able to then measure the carcass temperature of the tire. Whereas if you just measure the outside, sometimes the outside tread does not give a good understand or a good read per se on how the tire's going to be doing. From the team's testing and manufacturers testing, they've been finding that the carcass temperature really does a good job of predicting that, and that's what you see in F1. That's what you see in all of these qualifying. The teams are just really maximizing it, and that's what you hear on the team radios, that someone's tires are going bad. So it's pretty amazing how all the different areas sensors are being used on these cars.
And that's why if you go to a race or you see people at a race, you see a bunch of people in the pit stand. They're not just watching the race on television. They're literally got screens, and they'll have different engineers which have different responsibilities. Obviously, the engine manufacturer will have a tech there watching the engine performance. There'll be usually a car engineer watching just the tire pressures and making sure the car is safe and everything is going well. And they'll be watching steering inputs and throttle inputs, and then the performance engineers watching to see if anything strikes them. And with everything that we sell things that you can measure on a race car, but our output is used in math channels, which creates a whole bunch of different channels, like Miles mentioned on the center pressure, using the load cells and trying to figure out that aero balance is front to back. A lot of amazing stuff. So you have to have robust, accurate sensors to accomplish that and be able to trust the data.
Mm-hmm. Yeah. And really how this can help everyone from, the top levels of professional racing, like you talk about, from Formula One to NASCAR to IndyCar and so on and so forth, to the track day racer or whatever. It's amazing.
Go-karts.
Look, yeah, go-karts. Yeah. Look, I'm not an aerodynamicist at all. I don't even pretend to be, but I have a fairly decent understanding, and just having been around this for a while, and the things you see at a racetrack where you kind of scratch your head and go, but in a very easy way, in being able to gather some real data, like you were saying with, pressure sensors and different things like that. Amazingly how you could actually find what does and does not work on your car in literally a very simple way, right?
Absolutely. You see a lot of teams. That's why they invest so heavily in engineering. 30 years ago was, crew chiefs, and they're still important, but the engineering is just exploded across the board in every series. You go to NASCAR, for example, and it's an international series. I know it is an American series, but if you go and you walk and you talk to engineers, they're from France, they're from England, from Germany. Same thing with IndyCar, same thing with IMSA. It's just motorsports binds us together globally, and it's amazing how much engineering brain power is out there.
Mm-hmm. Yeah, it is for sure. And looking at this, there's so many fascinating things that you guys have. I wanted to ask you about the RMS business. I know that's a pretty big deal.
Yeah, our RMS business, they do the strain gauging. So that is done in-house here in Indianapolis. And we've been able to strain gauge many, many different types of parts. So basically the concept of the strain gauging, we put these gauges on these components, and then you're able to then start measuring the tensile loads through the parts, whether it's in rotation, torsion, whether it's in bending, or even shear. So you're able to then start having these gauges, and you could then start being able to extrapolate what the loads are on these components. And that's kind of what the different load cells start having. So it's a really, really impressive feat of technology that's been developed. And us having that in-house, being able to strain gauge different components for different teams, different customers, and being able to provide them with that data, they're able to make more educated, decisions based off of that. And it adds a lot of value to their programs, their testing, and even their racing.
Yeah, I mean, just literally being able to know what things are doing, what parts are being stressed, and where. I mean, again, just thinking of these things to know what's happening inside and underneath the race car is incredible to have that data. And I know that's a very important thing in talking about that, about things being accurate, being able to get not just data, but the right data.
Mm-hmm.
That's hugely important. And on the RMS side, we've invested heavily to ensure that we provide that. We've got a new digital amplifier we're about ready to introduce, and we've adjusted our pricing so we can get down to the lower markets, to be honest. We've done some deals with some of the feeder series, so we're the exclusive strain gauge for Indy Next and some others. So it's hugely important to stay on top of the technology and keep reinvesting in people and resources to deliver the product that the customers expect.
Let's talk about when you get we've got the sensors. We've contacted Texas and said, hey, I want to do this, and/or this. Well, now how do I read the data? What does that go into? What happens at that point?
Well, we play nicely with all tire mates, and we also play nicely with all the data loggers. So generally, you're either getting a digital output or analog output or a CAN bus outlet, depending on the car. CAN bus has been around for a long time. Was used, I think, started in road cars. It's like a train that travels to different stations. So it's a train with different packs of. Each car has different data on it. Comes to the station, and that station quickly says, "Hi, do you have what I need?" Or there's a quick communication. We see a lot of CAN bus taking off in motorsports because it allows them to put instead of doing point-to-point sensors, you have less wires, less cabling, less weight. So basically, we play nice with anything. Most of our sensors have multiple ways to communicate to the loggers. So we have a sensor that may be have a digital output, and then it can also have a CAN bus output. Yeah. One thing we're seeing more of lately is wireless sensors. That's taken a while for the battery technology to handle the heat and some of the vibrations, but we're seeing more and more wireless sensing going on to cars, which again reduces weight with less cabling and wiring.
That's pretty interesting. And when you say wireless, is this, as cars are pulling into the pit as you're standing next to it? Or, for example, like one of the first times I really started having an understanding of the sensors and the different things that you can do, like currently, say in NASCAR, we hear a lot about SMT technology where we're seeing, throttle and steering and different things like that. But I remember when I worked at Texas Motor Speedway, one of the IndyCar teams was there for a test. This was like the early mid 2000s. And I looked up at their screen and basically asked the "what's that" question, and this was the hey, all the drivers who tell us what they're doing in the race car, this is what's actually telling us what the drivers are doing in the race car. We talked about this. If someone says, they were all the way in the throttle, well, we can tell them, no, you weren't. Yes, you were. But they could literally do that real time, shock travel, all the different things as the car is going around the track. So how deep can this go? Either A, in real time, or B, once you get back and you're looking at the log of that lap or the laps you made and all of that.
Well, the real-time data is crucial at a test. For example, if you have your engineers, last thing you want in a test is a crash. So you don't want to crash, and you don't want to blow up a transmission, and you don't want to blow up the engine. So at a test, if any of the data looks wrong, anyone can call the car in. So if they see something that looks wrong, they'll immediately call the car in because something's going to happen that's going to be expensive or somebody gets hurt. During a race, sometimes they'll let them race because you can't do anything, but that's the importance of having real-time data. So our pressure sensors, our temp sensors, stuff like that. Obviously, this is an expensive sport. We know that. You don't want to blow an engine. Back in the day, like you said, when people said they were flat and they weren't, you'd go out and you'd go too far and blow an engine or blow a transmission because drivers just would exceed it. Now you've got alarm lights that go off on the dash so the driver can see it. You've got additional things that people can be watching in the pit booth. They might be seeing a temperature that's not at the danger point yet, but they can just see it rising, 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 and know if it keeps going, they're going to pass some threshold. So they could tap someone and show, hey, bring them in. We need to cool something off or check something. That's very, very crucial. I think it's made racing safer. We've seen the reliability. I mean, again, you talk about NASCAR and IndyCar and these series 30 years ago, and the attrition rate, maybe 10 cars would finish a race or 20 cars, and now almost everyone finishes if they don't hit each other. It's it's pretty amazing that the reliability. We almost have been spoiled because now when you see an engine failure, it's rare, primarily because usually they can catch it before it fails, or there's a lot of safe modes they can, if they see something, they can put the engine in some safe modes. So I think sensors have made racing safer. Mm-hmm. The sensors are expensive, but at the end of the day, they're not as expensive as the other components. And by buying them and using them, you can save on either crashing a car, blowing a motor, blowing a transmission, having a major tire failure.
Yeah, and I think the other aspect of that is the stuff that you do after the fact as well. So you then have all this data, and then the engineers, the teams, everyone, they spend a lot of time analyzing the data and taking a look and saying, hey, we were seeing some overheating on our brakes in this corner, in this scenario. And then you're able to start saying, hey, if we could do some ducting, can we do that? Then they make a change, and then they're able to validate that change or see if it had done anything or not. And you see that with testing. You see that, outside of the racing season during the off-season testing. And, that trickles all the way down. It starts at the top and it trickles down to the guy just doing track days who just wants to go a little bit faster. And he wants to be able to have some data to be able to make some changes, because we've had both. And it's really cool when we're able to provide the support to the big teams, but then also the one guy with his with his Porsche or with his car or his Mustang or something, and being able to make decisions based off the data makes those decisions, they get a little bit more of a payoff from there.
One quick story from Craig Hampson, who's been a long time racing engineer, was with Newman Haas for many years. Now he's technical director at Andretti Autosport. His car qualified first or second at Milwaukee years ago. So happy. I went up to congratulate him, and you would have thought his wife had left him. His dog died. Somebody stole his truck. He was as dismayed. I go, what's wrong? He goes, we're on pole, and I have no reason. I have no idea why. So the engineers want to know the why, good or bad. And I think that's what we do. And that's what all that downtime after the session is. He didn't know all the data showed the car was terrible, and they're on pole, and that drove him crazy. While his driver's drinking champagne on qualifying first or second. So they're very demanding, knowing his knowledge, and there's engineers, everyone out there can do stuff with it.
Yeah, and it's interesting. I always think a lot about, obviously the professional racers, the people who make a living doing this and a nice living. I think about the weekend warriors, the track day people, and all of that. And you had brought up the brakes, Miles. I mean, look, races have been won with brakes, lost with brakes, and cars have been crashed because of brakes. I mean, just that one component alone to truly know what's going on with what's happening with your braking and system and how you can adjust that's incredible.
Yeah. It really is. I mean, we start, kind of our bread and butter is one of these little INFT IR temp sensors. It's just a single spot, temp sensor. We have customers who use this to be able to measure their brake rotor temps. We have other components that measure brake caliper temps. But it's really cool because you have this little guy that has a single IR spot. And then with some development, you go up to this little guy, and this has 8 different IR spots. So you're able to then measure the gradient of the brake rotor itself and really can understand how it's heating up, how it's cooling down. And then that helps design or drive design decisions on how to, design the cooling packages of it. So it's like you said, safety, it's critical. And that's kind of the nice thing about our sport is you've seen how the safety's increased over the years and people's lives have been saved because of it.
Mm-hmm. If you would, Jeff or Miles, when you go to the Texys website, you look at the product offerings and different things you have, you'll see different brands that are there as well. Could you go over some of those and, give us a little more specifics on what each one does?
Yeah. So we've got our TechSense brand. So that's any of our main motorsport and even non-motorsport sensors, different types of whether it's temp sensors or load strain sensors, kind of inertial bodies. You've got pressure sensors, temperature sensors, just any type of sensing solution. That's kind of what that main brand does. We have another brand called Optel, and that one's really impressive because it uses a lot of fiber optics. And there's a lot of cross-pollination between our brands because, in the TechSense brand, we offer this fiber optic IR sensor. So it picks up on one end the temperature conductor, sends it through the fiber optic to the actual sensing element, and then that's able to get kicked back to the data system. So we all start working collectively. We also have our Skunk Works, if you will. It's our H2 Motronics. That brand and that subsidiary there really focuses on special projects. They're able to take things from the ground up, and they utilize all of our different sensing resources, and that also trickles into it. So we work very cohesively between our brands. We've already talked a little bit about RMS and how they work alongside us to be able to produce a bunch of good strain gauging solutions for our customers as well. And there's also LGS as well. So there's a whole bunch of different brands that we've got, not to mention our partnership with Vogel and the sensing solutions that they provide to their customers. And, it's a new partnership, and we're already seeing the benefits of that, the cross-pollination of our engineers. It's really, really impressive. So the future is really bright for us.
Yeah, and speaking of cross-pollination, a lot of times in racing, it's racing technology that trickles down to passenger car technology. But so much these days, we also see that going back the other way as well. Could you speak to that?
Yeah. It's been crazy. Back in the day, I'm old, so back in the days, my daughter likes to say, old timers. Racing kind of drove technology, and then through safety and costs, there's been restrictions over the years. And today, we were laughing, before the new NASCAR, for example, people would drive to a NASCAR race in a car that had more technology than the cars they were watching on the racetrack. With all the parking sensors and lane sensing and cameras, front and rear. So yes, there's that back and forth. And different challenges. Obviously, when we do stuff, we do a lot with the OEs, but mostly for testing. When they put stuff on the cars, they're trying to get it down really, really inexpensive. We're more in still in the high technology, high data rates, more expensive than going an everyday car. But who knows? That could change over the years. Right now, 100 of a sensor is a lot for us. When you get into that realm of automotive, it's 100,000, and you're selling it on pennies. You're making a penny per part, having been on that side before. But there is a lot of cross pollination. Is a great way to put it, and it's been a fun. And then we got the EVs. The EVs, we're actually through the Indy Next. We're on the Indy Autonomous program. So still strange seeing a car running around with no driver on it. But talk about a car that's heavily censored. It's fascinating, and it's hugely impressive. They just drove the cars at the Goodwood Festival. I believe it made it without hitting anything. So I was actually at a DARPA test back in the late 90s, where it went horribly wrong, and the autonomous car drove through the crowd of people that were there. It was quite ugly. Today they just drive. Now they're racing on racetracks with no driver. It's just phenomenal. EVs and autonomous. Everything is going more and more sensor laden.
Yeah, it's really cool getting to see how, as you get more desire to have hybridization as well as electrification in race cars, how that technology goes both back from the OEs back up to motorsport and from motorsport to the OEs. And it's cool when you start seeing how different OEs, let's just say, take engineering support and resources from motorsport. But it's really cool because you have those motorsport engineers who are familiar with our products, familiar with what they need to do, what they need to learn, and you bring that knowledge down to a road car level. You start being able to start seeing how our products start kind of spreading not only to this market, but other industries as a whole, aerospace, defense, where you have that ethos in motorsport, it being mission critical. It just jives really well with aerospace, especially rockets, as well as the defense market as well. So it's really cool seeing how everything just kind of intermingles and cross pollinates.
That is really cool. By the way, the crash avoidance technology I think is awesome in the autonomous cars. Don't ever let that get into, you know, like the ones that real people drive, because as a race fan,
Right.
on a closed
Right.
circuit, we don't want that crash avoidance. But
Yeah.
it's neat to know you guys could do all of that if you needed to, right?
Right.
That's awesome. Here's one thing that I'm fascinated with and I love. Tell us about the TM Fast brand.
Yeah, our TM Fast brand is really, really impressive, to be honest with you. It kind of pairs with our RMS as well as our strain gauging department in France, our main production facility. And basically, you take a regular bolt. This one's massive, just really to show. It's easier to show it at a trade show. And basically, what they do is we have this patented technology where we put strain gauges inside the head of the bolt. And then I could actually take this one off and show briefly. And we put some technology into here and some strain gauges onto the head of the bolt. And you're able to then measure the tensile load of the bolt when it's torqued up. And it's really, really impressive because you could have, you know, hundreds, thousands of these torqued up, let's say on a rocket where something is going to be very critical for that mission. And you don't know if, you know, something needs to be to a specific torque and not over torqued and not under torqued. You're able to then go around wirelessly and actually check the actual torque reading to, you know, a decimal point of what this bolt is been fastened to. So when you start talking about things like that, whether it's in aerospace, whether it's in a testing environment, it then ends up saving time, effort, and, you know, in some instances, lives as well. So it's a really, really, really neat technology. I mean, we are able to bring this down all the way to an M4 size. So that's what is that? That's it's smaller than a 1/4 inch.
Yeah.
So it's you know, we're able to put that in very small fasteners. Again, I just use these because when you when you're at a trade show, you're able to show, hey, let me wrench on this thing, let me see what it is, and you know, you can kind of start seeing what it is. But it's really, really cool being able to have that technology, and you know, in the aerospace market, being able to make sure that, you know, on planes everything's torqued up to the correct spec. We're able to then start instituting technology like this. You know, at the end, the QC line, the guy, he's able to walk through the assembly line and say, hey, all the bolts on this wing, they're good to go. We're good. And you're able to rely on it. And that's kind of been a really, really great feature of this TM Fast brand that we have. And it's really just a cross between, you know, TechSense and TM Fast and just Texas Group as a whole. We're able to really provide unique solutions to these, and it's our customers love it.
Yeah. Well, look,
you go ahead.
I would say you see a lot of places on a race car or race bike or anything like that where that would absolutely apply. I am curious, you know, because especially when it comes to racing series that conduct live pit stops, you know, we always worry about making sure that the wheel nuts are torqued or wheel nut, whatever it is, depending on which series. I mean, is this technology that could apply in that environment as well?
Yeah, absolutely. It's one of those things where if you just have the correct understanding mechanically where to put a gauge or two, whether it's on a nut like this or on you know, an actual, you know, a nut, you're able to then understand and see what you know, what those loads are, and it could then provide you kick that data back through a data system, and you could have that live on telemetry, and you could say, hey, you know, front left, that's there's something wrong with that one. It's not to spec or it's not to torque, and be able to just wait, don't send the car. So yeah, there's a lot of opportunity there to prevent a lot of you know, unsafe releases at times. So
That's pretty incredible. And as I told you guys earlier, every car dealership and oil change center throughout the world needs to have this
yes,
technology. You know,
yes,
it's one thing to have a torque wrench; it's another thing to use it and know how to use
oh
it.
yes,
Yeah. I've actually had to remove a seized oil drain plug from a car,
yes,
steel plug and an aluminum sump and that. Yeah, you're absolutely right. That'll be the. I'll get on the phone today and make some calls.
Yeah. That's how I learned how to siphon oil from the dipstick too, by the way, on a Fiat that I
Yeah.
used to have, because I could never get it off. But anyway,
Yeah.
the tire pressure monitoring system, if we could
Mhm.
circle back to that, because it's really some pretty incredible technology. And I think you might even have a slide on this too, Miles, just, what everything looks like and how this applies. And, again, gathering the data and knowing exactly what those tires are doing and where and everything, just how important it is and how much of an edge that you can get on the competition by having that knowledge with the data.
Yeah, it's really, really impressive. So this here is kind of a good slide that shows our TPMS sensor installed on a wheel. And you have this little rainbow pattern here. And we're able to measure 14 different spots within the tire carcass from where that sensor is mounted onto the actual rim. And you're able to measure the inside tire temps there. So it's really, really impressive being able to merge that technology. And our sensors not only measure that, they're able to measure the rim temperature. They're able to measure the relative humidity as well as the temperature inside the tire. So once you have a good understanding of what the tire is doing, you can then start predicting it. And once you're able to predict it, you can then start creating strategies of, hey, I need to do this to get my tire ready for, that the one lap where you're going to be able to put down the best time. So it's really, really critical. And being able to see this data during the race is really great as well, where they can kind of start seeing, hey, I just removed a little bit of downforce, and you can start seeing the tire temps change from there. And you can see and make decisions based off that. So it's a really, really impressive technology.
Mm-hmm.
Yeah, I think that's hugely important when, again, going back to talking to back in the day where you would talk to the driver with pressure changes and suspension changes and adding this, and the driver would say, yeah, it feels better, feels worse. Now you can almost see if it's better or worse, right? You can see if the tires, have you helped the tire work more efficiently? Have you hurt it? And then again, that feedback to the driver, hey, we've given you some help in this area on that corner or this corner or the rear of the car, and we could see it. And then it gives the driver more confidence to go hard for that fast lap and know when to go. We hear tire management is the word of the day in racing in almost every series you go to, and this is one of the ways that they measure that and help it.
Mm-hmm. Exactly. And I think a lot of the cool thing about having all this data is you're able to take these subjective responses that are subjective feedback from drivers, and you're able to put them to an objective metric. And once you start having these objective metrics, you're able to then start being able to make decisions, design decisions, or performance decisions based off of those. And that's really where you start seeing the milliseconds of improvement that you see at the top level of the sports, whichever team, whichever category, you start seeing that. And that's what everyone's chasing. So it's really, really impressive.
Yeah, and just the amount of opportunity you have there to adjust things, and whether it is adjusting the driver, hey, you're going into that too hot, you're putting too much on the right front or the left rear, whatever, whichever way you're going, however you're driving, and or the engineers or someone who is setting up suspension and different things like that, like, okay, why am I getting this here instead of getting that there? To have all of those data points with one sensor and everything that you're doing with that, it's invaluable. Like, to me, that seems like one of the more important things among all of the important things that you have.
Yeah, it's really cool seeing how our sensors go from this little guy to then having one that has 8 different channels. And then it's just like, hey, can we measure something else? Can we measure the tire temperatures in another way? So then we manufacture this strip where it's got, several different heads on this one strip, and you have one connector. And the nice thing about this is you're able to wrap this around. So this is really big on our motorbikes. Yeah. And you're able to measure when obviously the tires are leaning over and you're seeing massive, 60-degree lean angles, and you're able to measure the temperature on, the edge of that tread. And it's really impressive being able to understand and see the temperatures, and the teams are then able to make decisions. So then you have something like this, and then you're like, hey, you know what? I want to actually iterate it again. And then you come up with another version. And this is just a snippet of it. You could have up to 8 of these. And same thing, you could bend this around. You could kind of see the different temperatures. And then you end up having just this iterative process of design where you get to be able to measure things in a unique way, things that haven't been measured before. And it's just really start integrating all the technologies into more and more components. It's really impressive.
Mm-hmm. And looking at all this and talking to you guys as well, the one thing too that I like, look, hey, if you're an advanced degree engineer and all of that, this is stuff that you know. This is speaking your language. You know what to do with it. If you're a weekend warrior, just something simple as that, knowing what things are going, looking at the way this data outputs, and like you said, all the data logging companies and everything play nice with what you do. It's something you can figure out. It's something that you can now have another tool in your toolbox, literally and figuratively, of what you can do to make your car better. It's not, the advanced degree certainly helps, but there are things that you can do with limited knowledge that still help you with what Texas has to offer, right?
Yeah, exactly. It's, we have these little inertial bodies, which basically have accelerometers and gyroscopes in here. We're able to sell that to a guy who just wants to do track days, and he's able to have a better understanding of what his car is doing, what his inputs are doing to the car. And the nice thing about us being able to provide the support that we really kind of pride ourselves with, we're going to help them understand the data as well. If they're going to have questions like, okay, so how will this help me? It's like, okay, well, here's what we know, here's what we've seen with other teams, and here's how this will help you. And we're able to provide the same level of support to, the weekend warrior, the guy with his little car, or the whole race team. We're able to provide same levels of support. We they have our cell numbers. They're able they're able to text us. They call us. I have FaceTime customers. They've been showing me parts on their car and be like, and we don't want to do it like that, or that's really good there. So we go out of our way to really make sure we provide the best support to our customers.
All right, so let's just say whether I'm an IndyCar team who wants to get, suspension bending measurements to a weekend warrior who says, "Hey, I'm struggling with this. How can you help me?" We know you have a solution, but what's the best way to go about that?
Well, give us a call.
Yeah.
Yeah. I mean, so obviously the professional race teams know us, and I'd say there are times there's less engineering going on. They just know what they want. They call us. I mean, like we mentioned the two recent projects with the team in Hanoi where it does get interesting. Some of the funnest conversations are the weekend warriors because they almost don't know what they want. They kind of tell you what they're looking for. Everyone's looking for that magic bullet. How can I go to, you spend a lot of money as a weekend warrior, you go into the track. How can I make the best time and maximize my track time? What can I do? Well, what's your budget? What are you looking for? What kind of car do you have? And from that, with some accelerometers or gyroscopes or temperature, there's a lot you can give that's simple. Like you say, you don't have to be a PhD. If this is too hot, it's probably too bad. But if it's too cold, it's too bad. So what range do I want it to be in? Well, we can give you a ballpark that's pretty good, or a ballpark range on accelerometers that would work for you. If you can, depending on where you put them in the car, are you oversteering, understeering? You can kind of figure out where things are good or bad. So that's, I mean, we enjoy being challenged with questions, even outside the industry. I mean, I think motorsport with its hard deadlines, again, we can't ask them to postpone any race, but I think other industries are surprised by how quickly we can respond because we're used to it. Other industries don't have those hard deadlines like racing. So people call us up and they're surprised that we're usually able to help them or point them down a path that will get them the data that can make their weekend cost effective and hopefully successful.
And the best way I think to contact us is just through our website, texysgroup.com. You could also, our phone numbers are all there. So you could be able to give us a call our Indy shop if you're in America, call some of our international support as well if you're internationally. So that would be our best way.
And we have grown. We've grown from about a one-man show to we've got 6 people now working here in the U.S., 5 out of the Indianapolis office, 1 out on the West Coast. So we continue to grow. Sales have grown, and so we have to support the business. And we had a new starter this week on the RMS side who's been with Walker Racing and Monon Racing in the past, and then spent 10 years strain gauging parts for Harley Davidson. So we're building up our technical team and our support and what we can do, and we continue to invest in ourselves.
Well, the depth of your knowledge obviously speaks for itself in having you here, and heck, maybe I'll get to run into you guys this weekend with NASCAR
Yeah.
being there in your hometown in
Well,
Indianapolis. So.
well, if you're at the Chalk, we'll come by and say hi for sure.
Yeah, I will definitely be there all weekend long, so that'll be great. Gentlemen, thank you so much. Jeff, Miles, this was just fantastic. It's always a great learning process here with Race Industry Now as well, and we appreciate everything that we learned from you here today. Thank you.
Brad, thank
for
you.
having us.
Thank you
Thanks,
so
guys.
much. Thank you, Francois and Judy.
Thank you, Jeff.
you.
Thank you, Miles. Thank you, Thomas in France, who coordinated everything. I love this company. It's just they basically are based where I was born, a little town in France, and they have grown around the world, and it's a fantastic company. And I've known Philippe, the founder and owner, for pretty much as long as you, Jeff. So, but thank you very much for being with us today. This webinar has been recorded. It will be posted later on the ePortrait platform, distributed through our newsletter, our social media channel. We pushed Texys back on the homepage of the ePortrait platform, so please visit eportrait.com for more information and updates. Next webinar will be with Shop Monkey. Thank you once again, and goodbye.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePortrait really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
Where will you find Farea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.